Let's begin with the sine function. The purpose of the addition and subtraction formulas are to take a single sine expression where we have two things on the inside of our sine function and express it as a multiplication of two objects added together. So we'll take a look on the next slide at a particular advantage of why we care about the addition and subtraction formulas, but for now let's try to take a look at some patterns in our formulas for sine. So two things that always helped me remember the addition and the subtraction formulas for sine were the following. Sine stays on the outside, and cos stays on the inside. Also, the sign that I have here on the left-hand side of my equation is equal to the sign that I'm going to have on the right-hand side of the equation as well. And then I alternate x, y, x, y. Let's take a look at the following example where we're trying to find the exact value of the expression sine of 7 pi over 12. Now since pi over 12 is not one of our usual reference angles, this one's going to be very difficult for us to tackle head on. So what we can do is we can break up this fraction into two other fractions where we know the reference angle, and then we can apply either the addition or subtraction formula for sine. So what I've done here is I've taken 7 pi by 12 and I've broken it up into 3 pi by 12 plus 4 pi by 12. Why have I done this? Well, because I know that 3 pi by 12, this is pi over 4, and I know that reference angle, and 4 pi by 12 is pi by 3, and I also know that reference angle. Since I know both of the reference angles pi by 4 and pi by 3, now I can apply the addition formula for sines to rewrite this in a different way. Remember that the addition formula for the sine function says sines go on the outside, cos goes on the inside, we keep the same sign as we have here, and then we alternate pi by 4, pi by 3, pi by 4, pi by 3. Let's go ahead now and evaluate sine and cosine at these given reference angles. So here either write down your 1, 2, root 3 triangle and your 1, 1, root 2 triangle and figure out sine pi by 4, cos pi by 3, etc. Or go back to your first quadrant of the unit circle, in which case you can pull out these particular values of sine and cosine from the x and y coordinates of the terminal points. Either way you solve this, we should get that sine pi by 4 is 1 over root 2, or root 2 over 2. Cosine of pi by 3 is 1/2. Cosine of pi by 4 is also 1 over root 2, or root 2 over 2. And sine of pi by 3 is root 3 over 2. Multiplying together, we get root 2 over 4 plus root 6 over 4, for a final answer of root 2 plus root 6 over 4. Next up, I'd like to show you the addition and subtraction formulas for cosine. They look very similar to the addition and subtraction formulas for the sine function, but they have two big differences. The first one is that the addition on the inside of a cosine becomes subtraction on the outside. So the sign changes as we utilize the formula. The second big change is the cosine addition formula and subtraction formula begin with both cosines. So it goes cosine, cosine, minus sine, sine. And then we alternate xy, xy. Same thing for the subtraction formula. You do your cosines first, and then add your sine functions. In our last example, we're going to try to evaluate cosine of pi by 12. So once again, since pi by 12 isn't one of our reference angles, we want to break this up into either a sum or difference of two things that we can find reference angles for. In this case, good candidates are 4 pi by 12 and 3 pi by 12. If I take 4 pi by 12 and subtract 3 of them, I'm going to be left over with my original pi by 12. And we can simplify each of these into a reference angle that we know. So 4 pi by 12, we can simplify this into pi by 3, and 3 pi by 12, we can simplify this into pi by 4. And now we're good to apply the difference formula for cosines. So remember that the difference formula for cosine says write down our cosines first, followed by our sines. We have to switch the sign, and then we alternate pi by 3, pi by 4, pi by 3, pi by 4. Once again, either pull out your two special triangles or the first quadrant of your unit circle and evaluate all four of these expressions. Cosine of pi by 3 is 1/2. Cosine of pi by 4 is root 2 over 2. Sine of pi by 3 is root 3 over 2. And sine of pi by 4 is root 2 over 2. Simplifying, we get root 2 over 4 plus root 6 over 4. And we can add these together to get square root of 2 plus square root of 6 divided by 4. All right, my little epsilons, stay positive.